From disrupting mental health, it's now time to disrupt our DNA. Both of our next speakers have been fascinated with genomics since they were teenagers. One of them still is one. It's very fitting that this is a super fireside because it's very much a passing of the torch session, a two-way analysis of the past, present, and future of our journey inside the double helix. Please welcome possibly the youngest CRISPR expert on Earth, Ananya Chadha, in conversation with founder and CEO of Genome Medical, Lisa Alderson.
Hello, everyone. Genetics and genomics will completely transform humanity, so I'm so excited to be speaking with Lisa today about the future of genomics and what that might even mean. So Lisa, before we begin, it would be awesome if you could tell us a little bit about yourself and what is Genome Medical?
Of course. Thanks, Ananya, and great to see everybody here. I'm Lisa. I'm the founder and CEO of Genome Medical. I am a longtime entrepreneur, so I started my first company when I was still 19, just around a little over your current age. And this is now the 8th company that I've either founded or been a part of the startup team. And it's been such an exciting journey. I've actually been involved in the field of genomics since around 2000 when we sequenced the first human genome. And now at Genome Medical, we are a genomics technology and services company. And we're very focused on how do we bring genomic medicine into clinical care today. There are huge barriers in the industry. Predominantly, it's a very small specialty area of medicine. In the United States, there are only about 6,000 geneticists and genetic counselors for a population of 330 million. And globally, those numbers are even more dire. And so we have this super small area of genetic and genomic knowledge and expertise in clinical care, and yet it ultimately will march into all areas of medicine: primary care, cancer, cardiology, neurology, pediatrics. And so we actually have to lift up that entire clinical knowledge base to incorporate and bring genetics and genomics into the standard of care.
That's awesome.
You've been doing some super cool things in this field as well. Why don't you share just a little bit about your background?
Yeah, sure. So my name is Ananya. I've been working in gene editing labs for 2 years now. And we use this really cool tool called CRISPR, which allows you to effectively and very cost efficiently edit the human genome, or any genome. And the lab that I worked at in Toronto, the Cone Lab, managed to cure muscular dystrophy in mice, and now we're on to clinical trials. So super interesting space, and I get so excited whenever I listen about it. Yeah, so I guess to begin, since this talk is about genomics, well, what is genomics?
Sure. So we all have a genome. It's one of the #1 factors that affects our health, and yet only today do we finally have the medicine, the science, and the technology to actually sequence the genome, basically our DNA, our life code. And through looking at and interpreting that sequencing, we can better understand our predisposition to disease, the risk factors that help cause or create disease in us, as well as more accurate diagnoses, as well as ultimately selection of the right therapy. And so it's a tremendously exciting area of medicine. In fact, I think it's one of the greatest promises of the future to improve patient outcomes and quality of clinical care, quality of life, and actually reduce the cost of healthcare delivery, because this shepherds in the promise of precision medicine, which is bringing the right drug to the right patient at the right time. And if we could do that in a way that was much more knowledgeable and informed by our molecular makeup, we can have higher efficacy, we can have improved quality of life, and we can ultimately reduce inefficiency and adverse drug reactions.
That's awesome. All the different outcomes that can come from that are very exciting. So since the title of this talk is all about the future of genomic medicine, we're actually interested in seeing what you all think. So there's a Slido that you should be able to all vote for which future you think is one that we'll encounter. And if you guys ever have any questions, feel free to pop them in on the Slido, and we'll try our best to take them.
That's great. And just open up your Web Summit app and vote. And we'll give you a few minutes and bring up the results of how this audience thinks the future of genomics will play out and impact our medical future.
I guess in the meantime,
yes,
we can talk about what's one thing on your genomics wish list? Something that would really help you and people across the world move forward in the space, or government regulation, or more research, or what are your thoughts?
So I think we need very large-scale genomics research. Most research in genomics has been done on symptomatic individuals. And what we need is more in the healthy, well, and diverse population set. Ethnic diversity is often underrepresented in large-scale clinical trials, and genomic medicine is no different. And so there are some initiatives underway actually at a national level, both in the UK and in the United States and in other countries, to harness the knowledge of our genetic makeup, our DNA, to better inform quality of care and ultimately improve quality of life. And so as we amass these large studies into the millions of patients, think about the complexity of the biology of disease. We can start to look at genes, variants, conditions of interest, and how those manifest over time on a longitudinal basis, and really deeply understand what is causative of disease so that we can do a better job of proactively managing and preventing disease before individuals become symptomatic.
That's awesome.
I was going to say one other thing. Today in medicine, we largely wait for people to become ill. We then observe their symptoms, and we try to moderate or diminish those symptoms. And in the future, we'll really actually start to stratify patients according to their risk profiles and manage, if you look at this conference with 70,000 people, there are about 1 out of every 6 individuals who will have a molecular marker, something in their DNA that makes them more susceptible to disease or potentially already have a genetic disorder that is undiagnosed. 1 out of 6. So this is a very high rate that will change how we inform clinical care in the future.
Yeah, that's amazing. Our answers are up for the Slido. So what are your thoughts, Lisa?
Excellent. So the number 1 is our longest vision, the precision medicine equals personalized care for all, 75%. Routine use in diagnosing and treating cancer patients, 19%, and then the vast majority of the world's population being sequenced in 5%. We actually believe all of these will become part of the future. The question is under what timeline? So my prediction is that within actually the next 3 to 5 years, very near term, both genetics, germline genetics, as well as somatic testing, which means profiling the tumor cell to understand what therapeutic options might be most effective in treating cancer. I believe all cancer patients will be using genetics to better inform their care. The reason for this is if you look over the last 5 years, there's been a rapid progression where we used to just test for BRCA1 and BRCA2, genes implicated in DNA repair, which meant that if you had a mutation in one of those genes, you were more likely to be at high risk for cancer. Over the last 5 years, we've moved such that we now understand those 2 genes are only responsible for less than 1/3 of the cause of hereditary breast cancer. We now have 11 genes with NCCN guidelines and a total of about 80 genes that are implicated in one's risk for cancer. So in that 5 years, our knowledge base of what is causative disease has dramatically expanded. And as we're moving towards exome and whole genome sequencing, which means we sequence larger portions of the genome, there are actually a total of about 20,000 genes in the human genome. So when we used to look only at 2, that's a very small portion of our whole genome. And so with this precision medicine, we will actually, over the course of the next 10, 15, 20 years, combined with other therapeutic options, largely eliminate cancer. We'll be able to treat it much more effectively than we've been able to do in the past. The other one I will comment on is that within 15 years, I actually believe the vast majority of the world's population will have some form of genomic sequencing. That may not be whole genome sequencing, that may not be at birth, but the clinical utility around testing is expanding so rapidly that it's marching into more areas of medicine. And I believe we'll all basically have a very basic cancer and cardiovascular screen to understand our disposition for disease.
That sounds amazing. So that's kind of like 25 years in the future, all that type of stuff. What are your thoughts on maybe by 2100?
Yeah. So then it gets really exciting. I can see, so there's a few interesting technologies on the horizon that are really in more R&D at this point. One is liquid biopsy, which again is related to cancer. And that means that when we have a tumor cell in our body, it'll slough off some of those tumor cells and circulate through the body in our bloodstream. There are companies working on early detection such that you can detect that structure in your circulating bloodstream and know that you may have cancer in your body. And that allows us to then detect earlier, which means cancer is at its most treatable stage, which means long-term survival is much higher. So liquid biopsy, there's gene therapy, which means that we can insert nucleic acid in a cell and then use that as a drug therapy to actually fight disease. Immunotherapy allows us to activate or suppress our body's natural immune response, and again can be used to treat disease. And then there's this exciting advancement in CRISPR and actually gene editing, which starts to create the promise that if you have a gene that is not functioning properly, meaning it's not producing the proteins that it should and it's not regulating function in the body as it should, you could actually change the source code. You could affect the DNA strain and either create an addition or a deletion or take out a duplication and now have that as a properly functioning gene. And that means that you could actually in the future potentially eliminate disease or categories of disease. And this puts us on a trajectory where suddenly genomics has the promise to not only extend life, but frankly, vastly improve the quality of life, which is really what's most exciting.
That's amazing, yeah. So what's the most unexpected or unusual disruption that genomics will cause? Things maybe beyond our typical increased health span, lifespan, help us fight different disease.
So I spend the majority of my days thinking about how do I bring genomics to billions of people on the planet. But outside of the field of medicine, there are actually a lot of interesting applications starting to emerge around genetics and genomics, more in consumer applications and actually entertainment. And so if you think about this, if you've been sequenced, there are aspects of our genome that predict health, but there are also aspects that are traits and characteristics. And that can allow us to start to think about, for example, weight loss, nutrigenomics. The science isn't quite as advanced there yet, but it will be certainly at 2100 and out in the future, where we can optimize diet. Do you need a high protein diet or do you need a low carb diet? What is appropriate? But there's also markers that will detect things like, your like of cilantro. And so you can imagine in your Yelp app where you're looking up a restaurant and you're now at the restaurant, it might actually put some recommendations for you, personalized to you based upon your molecular makeup as to what nutrition might be appropriate and right, as well as what you might like. There's also a company called Helix that is building that equivalent of the Apple App Store, but for genomics. And there are apps in that site that allow you to select wines based upon your taste. There are apps that look at really interesting and insightful ways that are more in this entertainment and media. There are large consumer goods companies around weight loss, around skincare. So you can imagine in the future you go to the cosmetics counter and you're at Estee Lauder and you look up on your app and suddenly you have dry skin and risk of eczema, and so how do we now get you the right cosmetics and skincare? And so there's all of these ways in which it can start to move into more of the entertainment or consumer side of life.
That's amazing. Yeah. I saw a question from Slido and I was really inspired. I was wondering, what are your thoughts on genomics and potential discrimination? I know that there's the warrior gene, for example, and people with this genotypic response or mutation or sequence have been found to be more aggressive, or like typically those people with those genes end up with higher populations in prisons. And like, what are your thoughts on like the ethics and questions behind all of this?
There are huge ethical, legal, regulatory, and social implications of genomics. It really does take a body of both regulation as well as just thoughtful information around how do we use these technologies. So if we have the medicine and we have the science and we have the technology, what are the appropriate ways to apply it? And so, that's a hard question to answer because there's no black and white. I'll give one example though. In Israel, they have largely eliminated Tay-Sachs disease by providing carrier screening to most couples, sometimes even in advance of marriage. And so for a severe condition like that, which typically results in death and childhood, most would argue that that is a very positive.
For sure.
You're selecting, you're ultimately creating healthy individuals with a potential for longevity. But there's a slippery slope there. And where do you start to draw the line and say, do we start to use PGD, which is pre-implantation genetic diagnosis, around whether or not an embryo potentially has chromosomal disorders or genetic mutations? And in IVF, we already select the healthier embryo for implantation. But that starts to create this slipperier slope into traits and wellness. And how do you start to think about selection in ways that would go beyond that ethical framework that's being applied today?
That's amazing. So now to get some context about the present and how it will shape our future. 15 years after the genome was sequenced, there was so much promise that genetics would completely transform humanity. Have we realized that promise yet, or is it still being pushed back a little bit?
So it has felt, I would say, slow in the early days. So I was involved in the industry in 2000 at a company called Genomic Health, which was really one of the first precision medicine companies. And when we were sequencing the first human genome, it took many companies multiple years and $2.7 billion.
Wow.
Now we can sequence a human genome for more like $2,500. So in just 15 years, we have reduced the cost of sequencing by a factor of 1 million. That is a faster drop in the decline of sequencing costs than even Moore's law would have ever predicted. And so as we decrease the cost, we're also able to increase the application, because if it costs $2.7 billion, of course we don't sequence everybody. If it costs $2,500, we still probably don't sequence everybody. But at the point that that gets to be $100, suddenly it's much more cost effective to just sequence everyone and use that information to better inform clinical care. And so as the cost of sequencing declines and as the clinical utility increases, the point at which those two lines intercept is the point at which we effectively have population health screening for the masses. And so that is in line of sight. What I would say is that the biology of disease is extremely complex. There are some genetic disorders that are caused by a single gene mutation. There are others that are polygenic, meaning multiple genes can create an effect together. And there are others that are even more complex and take environment and other factors into consideration. And so think of this as a huge complex puzzle. We have about 2 billion base pairs in the human genome. Anything that can mutate generally will. And so that's like a factorial magnitude of complexity to really think through. And so like any complex puzzle, as you start to put the pieces into place, you actually accelerate to an answer. And so the way I think about it is over the last 15 years, like we've been working on, the corner pieces and a little bit of the edge, and we're getting a little bit more of the puzzle figured out. And now we're in this rapid acceleration of scientific discovery because we know so much more of the puzzle that's already already in place. And so we're going to see this continued acceleration of scientific discovery, as well as medical applications, as well as just, frankly, consumer interest. There are now about 20 million people in the US alone who have had consumer genetic testing. Globally, that number is much larger. And so as we kind of push the industry from the consumer side, as well as the medical and the scientific, more of the mainstream medical market, those two markets eventually will converge. Yeah.
That's amazing. Thank you so much for speaking with us all today. I know I learned so much, so thank you.
Thank you, Ananya, and thank you all. I appreciate it.